What if the asteroid never struck Chicxulub? What would ancient Earth look like millions of years later? Would dinosaurs still rule the planet, or would evolution create something none of us could ever imagine? This is the Lost Earth, a planet where dinosaurs still ruled. "66 million years ago, Earth reached a moment that could have changed everything. In our timeline, an asteroid struck the planet and ended the age of dinosaurs. But here, it never came. No impact, no global fires, no sudden darkness. The morning simply continued. Dinosaurs kept feeding, predators kept hunting, and young animals stayed close to their parents. To them, it was just another day. But that ordinary day became the greatest turning point in this alternate history. Because extinction does more than remove species. It tears apart food webs. Opens ecological niches, and gives previously limited groups a chance to take over. That is exactly what happened after the real end of the Cretaceous. Mammals inherited opportunities that had been closed to them for more than 100 million years. In this timeline, those opportunities never opened in the same way. The old ecological order survived, but surviving did not mean staying unchanged. Over the next millions of years, the climate shifted. Sea levels rose and fell, forests expanded and contracted, and new species appeared while others disappeared. On this version of ancient Earth, dinosaurs continued to evolve with the changing planet. Some became smaller and faster. Others became more specialized. Some lineages vanished completely. Evolution never stopped. The difference was that it was working inside a world where dinosaurs still occupied many of the major ecological roles. A young dinosaur born millions of years later would know nothing about the road not taken. It would simply inherit the world its ancestors had built. It would learn where to feed, where water remained during dry seasons, and how to avoid the predators that ruled its territory. Generation after generation, those relationships became deeper and more established. But there was a hidden cost to such success. The longer a species dominates one environment, the more dependent it can become on that environment. A giant herbivore can be perfectly adapted to a landscape, yet vulnerable when that landscape changes. A predator can become highly specialized, yet struggle when its prey disappears. Therefore, the question is no longer whether dinosaurs could have survived for millions of years longer. They already have. The real question is this: what happens when the creatures that ruled the old world must face a new Earth without ever having been replaced? And that is where the story truly begins. Because the new Earth did not arrive all at once, it emerged slowly through changing forests, shifting rainfall, rising temperatures, and landscapes that no longer offered the same resources as before. For the dinosaurs that still ruled this world, survival now meant adapting to changes they could neither stop nor predict. One of the clearest examples could be found among the giants themselves. A herd of enormous sauropods moved slowly through a forest, their long necks rising above the canopy as they stripped leaves from branches far beyond the reach of smaller herbivores. As they passed, they changed the landscape around them. Branches fell, vegetation opened, sunlight reached the forest floor, allowing smaller plants to grow. Insects and small animals moved into the newly exposed spaces. The giants were not simply living in the ecosystem, they were helping shape it. But that influence came with a cost. A landscape capable of supporting animals this large needed an enormous and reliable supply of vegetation. When rainfall patterns gradually changed and dry seasons became longer, some forests became more open and less productive. The herd could no longer remain in one place for long. It began moving farther between feeding grounds, following rivers and searching for areas where enough vegetation remained. Their size was still an advantage. It allowed them to reach food that smaller animals could not, but it also made them dependent on something much harder to control: a productive environment. A small herbivore could survive by eating scattered plants. A giant sauropod needed an entire landscape capable of feeding a giant body. And this is where the alternate world becomes more interesting. The dinosaurs did not need another asteroid to disappear. Some giant lineages could decline simply because Earth kept changing. Others could survive by becoming smaller, changing their diets, or moving into new habitats. Evolution was still reshaping the dinosaur world, just without the dramatic reset that had transformed our own. The giants had survived the greatest turning point in Earth's history, but survival had not made them invincible. It had made them deeply connected to the world they dominated. And beneath those enormous footprints, another group was quietly evolving in the spaces the giants could not fill. The giants had survived, but beneath their enormous footprints, another story was beginning. While Tyrannosaurus still ruled the land and Triceratops still moved through the forests and floodplains, small mammals were living in the spaces the dinosaurs barely noticed. One of them might have been a Didelphodon-like mammal, a compact animal with powerful jaws that could feed on whatever the larger predators left behind. It was not a rival to Tyrannosaurus. It did not need to be. Its advantage was simply being small enough to survive where giants could not. Then the generations passed. In our world, the extinction 66 million years ago opened enormous opportunities for mammals. But on this ancient Earth, that opening never came. Tyrannosaurus remained a major predator. Large herbivorous dinosaurs continued to dominate the richest habitats. The ecological space that mammals would later occupy was already filled. Yet evolution did not stop. Over millions of years, these mammals could become faster, more agile, and more social. They could also adapt to habitats the dinosaurs barely occupied, from the forest floor to the treetops and nighttime niches. But there was always a ceiling. Mammals could become smarter, faster, and more efficient, but becoming large meant entering a world already occupied by dinosaurs. Imagine one of these descendants crossing an open plain at dusk. In the distance, a massive sauropod herd moves slowly across the horizon. Above them, a large theropod watches from the edge of the forest. The mammal freezes, waits, and disappears into the vegetation. The mammals were not failing. They were adapting brilliantly inside a system whose highest positions were already occupied. Evolution did not guarantee that the most intelligent group would take control. It depended on opportunity. Perhaps, over the millions of years that followed, mammals could have continued evolving beneath the shadow of the dinosaurs. They would not have been waiting for their chance to take over, but building an entirely different kind of success. And that raises the next question. If dinosaurs continued to control the land, what would happen to the rest of the planet's energy, forests, and food webs? Because the longer this world remained under dinosaur rule, the more deeply their presence would shape the planet itself. The mammals had found their place beneath the dinosaurs. But the dinosaurs were doing more than occupying the land. They were changing it. Imagine a vast forest on ancient Earth, millions of years into this alternate future. A herd of giant sauropods moves slowly between the trees, pulling leaves from the canopy and pushing through dense vegetation. Behind them, branches break, sunlight reaches the forest floor, and new plants begin to grow. At first, this looks like destruction, but in a living ecosystem, destruction can also create opportunity. Insects find fresh plant material. Small mammals search through broken vegetation, and new shoots appear in the openings the giants create. Even the shape of the forest begins to depend on them. That influence could extend beyond the forest itself. Every tree stores carbon, and every leaf moves carbon through the atmosphere and soil. If giant herbivores continued to dominate for millions of years to come, their constant feeding could change where carbon was stored and how quickly it moved through ecosystems. This would not mean dinosaurs controlled Earth's climate. Volcanoes, oceans, rocks, sunlight, and moving continents would still shape the planet's long-term climate. But the uninterrupted presence of enormous herbivores could become another force within the ecosystem. Picture a fallen tree deep in the forest. Normally, it might decompose slowly on the ground, but when a herd passes through, vegetation is broken apart, smaller animals move in, and fungi and microbes gain access to the exposed plant material. Carbon locked inside living tissue begins moving through the food web again. Then the environment changes, rainfall decreases, rivers shrink, and forests become harder to replace. The herd must travel farther to find enough food. One young sauropod stays close to the adults as they move toward a distant river. Behind them, the forest slowly changes. Some trees disappear, smaller plants take their place, and the food web adjusts one species at a time. This is the hidden cost of stability. A world ruled by dinosaurs would never remain frozen in the Cretaceous. Continents would move, climate would shift, species would disappear, and new ones would evolve. But the ecological machinery would follow a different path because one enormous event never happened. There would be no sudden removal of dominant dinosaurs and no massive opening for mammals to become the planet's largest herbivores and predators. Instead, evolution would keep modifying a system that already worked. From space, this Earth might still appear remarkably alive, covered by forests, rivers, shallow seas, and landscapes shaped by generations of giant herbivores. The dinosaurs would not simply survive the extinction that never happened. They would become part of the reason this alternate Earth became the world it was. And that leads to a more unsettling question. After 66 million more years of evolution, would dinosaur intelligence remain locked inside the old ecological system, or would one lineage finally learn to change the rules? The answer might begin with something much smaller, a lineage descended from troodontids, living millions of years after the extinction that never happened. They are not the strongest predators. They survive by paying attention, remembering where prey gathers. Recognizing danger, learning from older members, and coordinating with one another. A failed hunt teaches them something. A dangerous route is remembered. A young animal watches an experienced adult and copies what works. Over millions of years, small advantages in memory, learning, communication, and cooperation could accumulate. Natural selection would not be trying to create a genius. It would simply favor animals better at solving the problems their environment presented. Ornithomimids living across open landscapes could benefit from sharper awareness and coordinated movement. Large herbivores could rely on social memory, seasonal routes, and stronger bonds between adults and young. Even small mammals, still living beneath the shadow of the dinosaurs, could continue developing better memory, communication, and problem-solving abilities. Intelligence would have many forms because evolution would keep rewarding whatever helped an organism survive. But here is where this ancient Earth begins to differ from our own. Intelligence does not automatically lead to technology. A predator that remembers where prey gathers is intelligent. A herd that coordinates its movements is intelligent. An animal that learns from others is intelligent. None of these abilities require cities, machines, or civilization. They only need to make survival more effective. In our timeline, human intelligence eventually became transformative. It allowed one species to reshape landscapes, control energy, build technology, and alter the planet on an unprecedented scale. But evolution was never required to reach that outcome. It was only one path among many. On this Earth, the dominant ecosystems would still be changing. Predators would still compete, climates would still shift, and species would still disappear. Stability would not mean peace. It would simply mean that no single catastrophe had erased the old system and opened the door to an entirely different one. So intelligence could become more sophisticated without becoming revolutionary. A smarter theropod might simply become a better hunter. A more social herbivore might become better at protecting its herd. A clever mammal might become better at surviving in the spaces left beneath the giants. The world would reward them for mastering the system, not necessarily for breaking it. Imagine that trudentid group again at dusk. One young animal wanders too far from the others. An adult notices and gives a short call. The young animal turns back. Nothing dramatic has happened. No tool has been invented. No civilization has begun. Yet that simple moment represents millions of years of evolution, memory, communication, learning, and cooperation working together. The intelligence is real. The progress is real. It simply leads somewhere different, because on the lost Earth, evolution was never trying to create us. If the asteroid never came, the oceans would have their own survivors. Among them were the mosasaurs, giant marine reptiles that dominated many late Cretaceous seas. In our timeline, they vanished 66 million years ago. But on the lost Earth, imagine that one lineage survived the catastrophe that never happened. What would happen next? Imagine a young mosasaur-like predator moving through a warm coastal sea. It follows an older animal along a reef, watching how it approaches a school of fish. The adult suddenly turns, cuts across the reef, and intercepts the prey from the opposite direction. The young predator follows. It is learning the landscape, the timing, and the behavior of its prey. Millions of years later, its descendants would no longer be identical to their Cretaceous ancestors. Some might become streamlined hunters of the open ocean. Others could specialize in shallow coastal waters or deeper seas. Fish would evolve faster bodies and stronger defenses. Sharks would continue competing for the same resources. The ocean would keep changing, but one thing would be different. The mosasaur lineage would still be there. In our timeline, the extinction removed these giant marine reptiles and opened ecological opportunities for other groups. Over time, marine mammals expanded into many of those roles, and whales eventually became some of the largest and most influential animals in the ocean. But on this lost Earth, those opportunities would not begin from an empty stage. A powerful marine predator lineage was already occupying them. That would not stop evolution. New predators could still emerge, old species could still disappear. And mosasaurs themselves could evolve into forms their ancestors would never have recognized. But the direction of that evolution would be shaped by a world where the old rulers were still competing for space. The ocean would not remain frozen in the Cretaceous. It would become something new, built on an ancient foundation. And that is the real consequence of the mosasaurs surviving, not that the ancient world remained unchanged, but that one of its dominant lineages was given millions more years to shape what came next. So what would that world look like from above, after millions of years of evolution without ever being reset? From above, this lost Earth would look surprisingly familiar. Green forests would still cover vast regions. Oceans would still stretch between moving continents. Climate would still change, species would still disappear, and evolution would still move forward. But one thing would be different. The asteroid that struck Earth 66 million years ago never arrived. Without that impact, the dinosaurs would not simply remain frozen in the Cretaceous. They would continue evolving, competing, and adapting to a changing planet. Some lineages would disappear. Others would become faster, smaller, more specialized, or more intelligent. Mammals would continue evolving too, but without the enormous ecological opening created by the extinction, they might never become the dominant large animals we know today. The same would be true of the oceans. Marine reptiles could continue evolving alongside fish and sharks, filling roles that, in our timeline, were later transformed by whales and other marine mammals. So this would not be a world that failed to evolve. It would be a world that evolved along a different path, and that is the real significance of the asteroid. It did not simply end the age of dinosaurs. It removed an entire ecological system and created opportunities for another one to emerge. We often look at human history as if our existence was inevitable. It was not. If that asteroid had missed Earth by only a few minutes, the future could have been completely different. There might be no humans looking back at the dinosaurs today. There might simply be another living planet, still ruled by descendants of the creatures that once dominated ancient Earth. The dinosaurs did not need to become more intelligent than us. They only needed the old world to survive. And if the asteroid never arrived, perhaps the greatest mystery would not be what the dinosaurs became. It would be whether our story ever began at all. This is only one glimpse into the countless paths life could have taken. If you want to explore more lost worlds, ancient creatures, and forgotten chapters of Earth's history, subscribe to the channel and join us on the next journey. Thank you for watching.